CMOS, so you will not face any difficulty in understanding the operation of gates using the CMOS. So let us start. Okay, I have not presented. Okay. Okay. So today's lecture number 8 or 7. 8, right?
Sir, it's 8.
Okay. Thank you. And Mugdha, you are not in the group, right? WhatsApp group.
I am, sir.
Oh, you are there. Okay. So today is 7th February 2022. So today basically we will study about the logic implementation. Logic implementation by CMOS. By CMOS, that is MOS transistor. So CMOS transistor. Here the C stands for the complementary. So whenever we discussed about the type of MOS transistor, then during that time I mentioned this type of transistor, CMOS complementary. Okay, so first of all we will discuss about the NOT gate. Let us talk about the NOT gate. So if you talk about the symbol of NOT gate, or you can say inverter, both are same. So you can also say the inverter. So if you talk about the symbol, then the symbol of NOT gate or inverter looks like that. See here, there is only one input, or you can say this is input, and here there is one output. So this is the symbol of inverter, or you can say NOT gate. So what are the truth table for the NOT gate? Anyone remember? Okay.
Sir, it inverts 0 gives 1 and 1
Okay.
gives 0.
So let us talk about the input, that is A, and out. So if you will provide the input 0, then you will get 1. Logic 0, not 0 and 1. We can say logic 0 and logic 1. So whenever you provide the logic 0 in the input, you will get logic 1 and the output. Similarly, if you will provide the logic 1 in the input, then you will get logic 0 in the output. So this is the symbol and truth table. But do you know the design of the inverter? How we can design the inverter? No, right? Because till now we don't know how to design any inverter or any NOT gate. So today we will learn how we can design this type of gate, logical gates, using the CMOS transistors. So the complementary means we have to use both type of MOS transistors. Like how many types of transistors? CMOS transistors? There are two types of CMOS transistors. There are two types of MOS transistor, that is N type and P type, right? So complementary means we have to connect the NMOS and PMOS in series. And we know very well, for any type of MOS transistors, mostly there are four terminals, right? Gate, source, drain, and body, right? So okay, so body we will neglect because we always connect the body to the ground, or you can say we can say to the zero potential. So okay, we will neglect the body terminal, but mostly there are three terminals we can talk about: the drain, gate, and source. So which is the input terminal? Out of the three terminals, which one is the input terminal? Gate.
A.
Good. So we know very well the symbol of, we also know the symbol of NMOS and PMOS. So let us connect the NMOS and PMOS in series so that we will get the CMOS structure, that is complementary metal oxide semiconductor transistor. So let us connect in series So here you can see okay. So we have to provide here the same input, that is we have to combine here. Let us see the structure. Here this is VDD, or you can say the logic 1 you will give here, or you can say VDD. So and from here we are getting the output signal. Here also this is ground, or you can say logic 0, or in technical term it is known as the VSS. Okay. So this is the general structure of inverter, or you can say CMOS structure. General structure. Structure. Okay, of inverter. Now here I would like to ask you which one is the PMOS and which one is the NMOS transistor here, so that we can understand the operations of this structure. So which one is PMOS?
Upper one.
Upper one. So upper one is PMOS. Very good. And lower one is known as the NMOS transistors. So for NMOS transistor, what will be the input voltage? Input voltage, yes, input voltage for gate. It should be greater than 0 or it should be greater than 1. Sorry, greater than 0 or less than 0?
Greater than 0.
Greater than 0. So we know very well for NMOS transistors to operate in the linear or saturation region, the gate voltage should be greater than threshold voltage, or you can say positive voltage we need to apply in the input terminal. What about the PMOS transistor, Mugdha? What will be the nature of the voltage for the PMOS transistors to apply at the gate terminal? It should be negative. Okay, so always remember. So there is an analogy between the NMOS and PMOS. So just whatever the voltage we will apply at the NMOS transistors to operate in the linear or saturation region, just you have to apply opposite bias to the PMOS transistors. So there is an analogy. So you have to remember, if you remember everything about the NMOS transistor, then you can definitely correlate for the PMOS transistors. Okay, so let us talk about the operations of this device.
Sir?
Yes.
सर इसमें आपको पता कैसे चला कि फर्स्ट वाला जो मॉस है वो पी मॉस है?
Exactly. That's why, if you remember in the first lecture, I guess I already explained about the symbol. So here, see, this is bubble, right? Here you
Yes,
can
sir.
see. So it means that if you remember the symbol of PMOS transistors, so symbol of first we need to discuss about the symbol of PMOS transistors. PMOS. So the symbol of PMOS is like that. Okay, this is also the symbol of PMOS. You can see here the source is there is drain, gate, and source, and symbol is also like that.
So for PMOS, the arrow should be outwards.
No. If you remember, what is the symbol for N-type transistor? NPN.
Yes, sir. Arrow should be towards the outer side.
Right? For the NPN, if you remember,
Yes, sir.
this is collector, this is base, and this is emitter, right?
Yes, sir.
And
Yes,
what about
sir.
PNP?
Arrow will be opposite side.
Right? That is true,
Yes, sir.
right? So similar, same logic you have to apply here. We are talking about the PMOS transistors, right? So it will be like that. So let us see: drain, gate, and source. What about the NMOS? These are the PMOS. So that's why this is the reason I always suggest you all, please revise the last lecture so that you will not
But
face
in
any difficulty.
lecture one you took source at the top and drain at the bottom.
Source and drain, source and drain in case of NMOS, in case of MOS transistors, I told you the both are symmetrical. if you remember my sentence. So this is a symbol of NMOS. Okay, if you want, then I can show you the first lecture. NMOS, right? Oh, this is NMOS. NMOS transistor. Okay, so let me discuss the first lecture so that you can understand. Where is the first lecture? Okay, wait, lecture 2.
Sir?
Yes, wait. Where is lecture 2? Ah, this is a symbol. This is, you can see here. Right? You can remember now?
Sir?
Yes.
Sir, current is supposed to flow from drain to source. That's why the direction of arrow should be from G to S in PMOS.
G to S.
Yes, sir. Positive charges will flow from drain to source.
So what will happen in
So
that case? So
that's
it will be
why,
outward.
yes, sir.
No. Gate to source current doesn't flow. Either the
Sir,
current
but
flow
on
from
the
drain to
internet
source.
also, the symbol used is
Forget
outward.
about the internet. Whatever I am teaching you, just you have to follow that.
Okay.
The current flows only from source to either source to drain or drain to source, not from gate to. How can you say that the current will flow from gate to drain or gate to source? Because gate is isolated from the body. Gate terminal is isolated from the body through the SiO2 layer. Then how can you say that the current will flow from gate to drain? The gate current will be 0. And I have already discussed about it. The gate current will be 0. Why it will be 0? Because gate is isolated from the body of bulk semiconductor. So it is isolated. If something is isolated from the bulk semiconductor, then can you assume the current will flow? In that case? Yes?
Sir, in the last thing, Tina sir told us that the direction of the arrow indicates the flow of the electrons.
So that's why I'm telling you, current will either flow from source to drain or drain to source, not gate to source. How can you imagine if you remember the device structure, let us say, okay, let us draw the structure once again. N plus P type substrate. This is the insulator. Insulator means SiO2 layer. And here on the top, there is a metallic contact, that is gate. And here, drain. And let us say this is a source. Okay. So what do you think? If I ask you about the gate current, Ig, what will be the value of Ig here?
Yes, sir, 0.
0, right? Why it is 0? Because this gate terminal is isolated from the semiconductor. This is semiconductor. And this is SiO2 layer, which is insulator. So what is the definition of insulator? Insulator have electrons and holes? Or insulator can conduct the electrical current?
No, sir.
Then
No,
how
sir.
can you say that the current will flow from gate to source or gate to drain? The current will either flow from drain to source or source to drain, because there is a channel here. Channel means it consists of electrons there. It consists of n type of carriers there. So that's why forget about whatever you have learned in the semiconductor. If you will ask me, then I will start teaching you the semiconductor. it's very well known that in case of insulator, the insulator does not conduct any charge, does not conduct any electrical current. So how can you say that that current will flow from gate to source or gate to drain?
Yeah,
Okay,
that
so
was
forget
drain
about
to
this.
source. I accidentally said gate. Please don't
Okay,
mind that.
so we know depends on the biasing, the current will either flow from gate to, sorry, drain to source or source to drain. So that's why we can also write in such a way that, listen, let us talk about the NMOS transistor. Okay, so what we write? IDS, right? Means current is flowing from drain to source. Whenever we will write ISD, means what does it mean? Current is flowing from source to drain. So in that case, can you write in this way? Sign negative represents the opposite direction. So can we write in this way?
Yes, sir.
Right. So that's why I told you. Current will either flow from source to drain or drain to source, but not from gate to. So both are same. Just the direction will be different. Okay. So let us focus. Because today I have to go to office. So let us focus on the CMOS transistor. That is an inverter. How it will work. So we know very well the transistor operates in three regions, right? Cutoff region, linear region, and linear region is also known as ohmic region. And what is the third region?
Saturation.
Saturation region. So when the saturation occurs, when the pinch off occurs, right? So after pinch off voltage, the current becomes constant with respect to with an increase in drain voltage, right? Okay. So let us focus here on the operations of this device. So here, always remember whenever we talk about the logical gates, right? So logic gates. So we have to assume here first that 5 volt is represented by, roughly you can say 5 volt is represented by logic 1 and 0 volt is represented by logic 0. So we have to remember. But practically what happens, there is a certain range. Let us say 4 to 5 volt is known as the logic 1 and 0 to 1 is known as the logic 0. It depends on the design consideration. So roughly here theoretically we can assume that 5 volt is the logic 1 and 0 volt is known as the logic 0. So this is the theoretical concept you have to remember. So now let us focus on the operations of this device, how it will work, and based on that we can only move towards the AND gate and OR gate. So okay, how can we change? Okay, so first point, case 1 we have to think, we have to see here what will happen if we will apply so whenever you will apply the logic 0 in the input terminal, then what you will get at the output? What will happen if you will apply the logic 0, apply logic 0 at the input of the above structure or above device structure, 0 at the input of CMOS transistor. Okay, so what will happen in that case? If you will apply the logic 0 at the input of CMOS transistor, then you can see that what will happen. So for this case, the N transistor, that is, this is NMOS transistor, right? So if you will apply the 0 volt here, then what do you think? NMOS transistor will operate or it will not operate? Yes.
So not operate.
Not operate, right? So for the logic 0, that is 0 volt input, the NMOS transistor will not operate, means it will not turn on, because to turn on the NMOS transistors, the gate voltage or input voltage must be greater than 0, right? Must be greater than VTH, you can see. But however, if you will apply logic 0 here to the NMOS transistor, to the PMOS transistor, then it will be inverted, right? This is bubble. So what will happen due to the bubble? Here it will, where it will, here the input will be 1, right? Okay, so for the 0 voltage, the PMOS transistor will turn on. And also you can see that the VDD signal, VDD terminal, it is connected to 1 volt, or you can say logic 1. So you will get in the output that is 1. So here you can see that in this case, inverter shows a logic 1, logic 1 at the output, logic 1 output corresponding to a logic 0 input. Okay, this can be ensured by the P transistor. How you are getting the logic 1? Because you are, if you will apply the logic 0, that is 0 volt in the input terminal, then in that case PMOS transistor will turn on, PMOS transistor will turn on, and since there is VDD terminal, that is drain terminal, is connected to logic 1, then you will get the output logic 1. However, for the same input, that is logic 0 or 0 volt, the NMOS transistor will be in off state. It is not turned on, because the voltage is here. If you see, for let us say this is for 0, what will happen here? The VGS or VGS is less than 0, then in that case it will not turn on. Okay, let us start right here. So let us talk about the input. So input 0, so NMOS and PMOS. So what will happen if you will apply input 0, then NMOS transistor will off, right? And PMOS transistor will be on. What will happen if you will apply the input 1, that is 5 volt, then it will be on. And what about the PMOS? It will be off. Okay. So the inverter shows a logic 1 output corresponding to logic 0 input. So this can be ensured by a PMOS transistor whose source is connected to whose source is connected to a logic 1. So I have already defined the meaning of logic 1 and logic 0. So just you have to correlate. Logic 1 means 5 volt. So logic 1 source, that is VDD, and the gate is provided or logic 0 stimulus. Stimulus means excitation. So do you know the meaning of excitation in technical term? Excitation means input signal. So inverter shows a logic 1 output corresponding to logic 0 input, and this can be ensured by the PMOS transistors, because PMOS transistor will be turned on, right, and NMOS transistor will be turned off. So as in this condition, the operation we can understand as, in this condition, the N transistor will be off, the NMOS transistor will be off, that is That is, there is no current path. So why it will be off? What is the physics behind it? Yes. Why the NMOS transistor will be off for logic 0? Logic 0 means 0 volt. Why it will be off?
Because there would be no channel.
There will be no channel. No channel means there will be no current path, right? So no current, that is, there is no current. Very good. No current, or you can say no current path. No current path means channel here. Channel. So there is no current path between the output node and the ground node. Ground node. Okay, so as in this condition, the NMOS transistor will be off, and the PMOS transistor, or you can say PMOS channel, we can say, and the PMOS transistor will be on. Will be on. So will be on, it means that there will be a current path, or you can say channel, right? So all be on. So as a result, it means that the PMOS channel, the channel in the PMOS transistor, okay, the channel of PMOS transistor. Okay, so on means which the channel will be in which state, in which mode of operation, I mean to say that. Cutoff, linear, yes,
Saturation.
saturation. It will be linear region, you can say. Saturation means there will be no further change in current, right? So
Okay.
here you can see it is in ohmic region, linear region. So it means that the channel of the PMOS transistor is in the linear, and linear region is also known as ohmic region, right? And ohmic, or you can say resistive region, both all are same. The meaning will be remain same of operation. So one obtains the perfect logic 1. So for that you will obtain perfect logic 1. Logic 1 at the output node. So do you know the function of wire? Simple wire. If I talk about the simple wire, then what will happen in that case? Do you know the operations of simple wire or use of simple wire? Yes. Okay, let us talk about here the case 2. So case 2, it means that you have to apply here we are applying logic 0, right, at the input. Case 2, we have to apply logic 1 at the input terminal. Okay, so what will happen if you will apply the logic 1 at the input terminal? Then can you guess what will happen in that case to the PMOS and NMOS transistor? Just you have to see what will happen, which one will operate and which will not operate. In that sense, I am asking. Yes, whenever 1 means VGS, 1 means 5 volt, right? So if you will apply the 5 volt to this device, to this configurations, so what will happen in that case? NMOS transistor will on, right? Okay. So for apply whenever you will apply logic 1 at the input terminal, then in that case you will get. So let us talk about this things similarly. So logic 0 output will result from logic 1. will result from logic 1 input. But how it happens basically? So what happens in that case, the NMOS transistor, the NMOS transistor connected in the bottom, right? NMOS transistors connected in the bottom, it will turn on, right? In the bottom, realizes this voltage, realizes this uh, this input terminal, the input excitation, when its gate means input terminal is given a logic 1, input, and its source, if you talk about the source here, so source is connected to ground. If you see the structure, this is the source and this is the gate and this is the drain. So if you see here, the source is connected to ground, 0, logic 0, or VSS you can say. In technical term, it is also known as VSS. So its source is connected to logic 0. So what will happen in that case? Logic 0, or you can say ground or ground. So ground means VSS, or you can say VSS. Okay. So what will happen in this case? In this case, the NMOS transistor channel, the NMOS transistor, because definitely there will be a channel, right, for voltage greater than 0 for NMOS. So NMOS transistor channel will simply act as a wire. Channel acts like a wire. Remember, so this type of questions may be asked in the quiz, resulting in a logic 0 at the output, while PMOS transistor channel is simply divided. PMOS transistor is channel is simply divide. So what do you mean by divide? Yes, what is the meaning of divide? Of
No current.
any conducting means separated, right? Any conducting channel. Okay, now I would like to ask you, I asked you about the wire. Let us say you are applying a voltage V is equal to, let us say 5 volt, and here due to any reason the terminal, let us say this is A and B. So A and B terminals are short circuited, and if I ask you to find out the VAB, then what will be the voltage drop here? Yes?
So 0.
0. Right? Because for short circuit, we know very well, for the short circuit, the voltage drop will be 0. So similarly, whenever you apply the logic 1 in CMOS configuration to the NMOS transistors, so channel will act like a wire. So you will get the logic 0 at the output. Now the next point is that therefore the inverter can be best considered as the central part at the digital design. Means but it means that by using the inverter, by using the CMOS inverter, we can design any gates like AND, OR, NAND, NOR, and you have also heard about the combinational circuits such as multiplexer, demultiplexer, right? Encoder, decoder. Have you heard this term? Yes.
Yes, sir.
So
Yes, sir.
we can design those combinational circuits and as well as sequential circuits also. So what is the sequential circuits? Like, so we can design any logical circuits, any digital circuits using this inverter, this CMOS transistors. So therefore, we can consider, therefore, the inverter, that is CMOS structure, can be best considered as the, that's why this topic is very much important. This subject, I mean, you can, because most of the people among you are very much interested in will be interested in embedded VLSI design and coding and everything. So in coding or in digital world, we always deals with the 0 and 1s, right? So therefore, you can design, if you understand the physics of VLSI, then you can design anything, any logical gates, any digital device as the central part of digital designs. And if anyone is interested in designing the sensor or modeling the sensors based on MOSFET transistors, he or she can contact me. We will design and we will carry out the research work based on the NMOS transistors based biosensors. So through knowledge, that's why I told you, through knowledge of or you can say understanding of its operation, that is above operations, CMOS operations and properties, is required to design more complex structures such as NAND and NOR gates or adders and multipliers. Okay, so now let us talk about the AND gate. Just give me 5 minutes. So if you talk about the AND gate, so how many inputs are required to form the AND gate? Yes?
Sir, 2.
2, right? So let us talk about the symbol of AND gate first. So these are the symbol of AND gate. Let us say there are 2 inputs, that is A and B. And in the output, if you will get F, so what is the functions for the output? Anyone remember? No, right? So it is the product of both the input terminals, or you can say A, B. So if we talk about the truth table, so here I assume you people know the product, addition, subtraction of the logical digital number, binary numbers. So I'm not going to repeat those things because you have already studied in first year, that is in basic electronics. So let us talk about the truth table for 2 inputs, that is 0, 0, 0, 1, 1, 0, and 1, 1. So now you will tell me what will be the output, that is F for 0, 0. Do you remember?
So 0,
0. Okay. What about the 0? What will be the output for 0, 1?
0,
0. And 1, 0?
0,
0. And 1, 1?
1.
1. So this is the AND gate. So this is the basic truth table and symbol. Now we will talk about the OR gates. So for OR gate, how many inputs are required? This is the symbol, that is A and B, and F is equal to, what will be the expression for OR gate? F is equal to
A plus B.
A plus B. So now we can truth table based on the functions of output, that is, let us say this is A, B and F. So okay, 0, 0, 0, 1, 1, 0, 1, 1. So now what will be the output for 0, 0?
0,
0, and 0, 1,
1,
1, 1, 0,
1,
1, and 1, 1, 1.
1.
Right? Okay. So this is the basics about the OR gate and AND gates. And I would request you all, please revise the truth table for the NAND gate and NOR gate. So based on that, we will, in the next lecture, we will study about the combinational logics. Combinational logics means AND gate, means NAND gate, NOR gate, AND gate, and OR gate. So first, in the next lecture, we will discuss about the AND gate and OR gate based on the CMOS structure. And then after that, we will see the NAND gate and NOR gate. So these are the syllabus for your unit 1. So in the next lecture, we will complete the unit 1. But if you are interested in learning how we can design the multiplexers, adders, and all everything using the CMOS transistors, then if you are interested, then I can teach you. But I will take the extra lecture for that. So what do you say? You people are interested in learning the adders, subtractors, multipliers, multiplexers using the CMOS? Right?
Sir,
Yes,
I'm not
sir.
sure.
Are you
Like,
sure?
how will we do it?
Yes, sir.
How will we do it means?